Yesterday we completed coefficient alpha and Bravo. The last coefficient which we saw was the induced P. Induced P which is caused because of vertical structure forward or aft of the compass. These are the masts, cranes, the funnel. Funnel being the biggest structure affects the compass the most. So Flender bar basically the corrector for IB corrects the deviation generated or the deviation created because of the funnel. So that's what we saw yesterday. So today we will be moving into our next coefficient. First we will go into coefficient Charlie and delta. Along with these, we will also see some typical questions which come in the exam. One of the questions is, if on a ship you have IB and IC, both are present together, how you do a combined correction? Then a similar kind of question is there in delta and eco also. So ready beta? Okay beta, great. So ready? चले आगे बेटा, coefficient Charlie.
Excuse me, sir.
Go ahead beta. Go ahead.
Yes, sir. Like this, like you put this cranes and funnels. The magnetic field enter from the top and coming out from the keel of the vessel, right? And we
Right.
put our flinders bars like that also. The blue mark is on the top and the red mark is in the down. So it will not be reverse. In this case, sir, only forward and aft we will check which area is the predominant factor of the induced magnetism.
That's correct beta. We will not reverse the polarity of the Flender bar, but we will change the direction in which the Flender bar is. Okay. Reason for that is beta कि जो Flender bar है, it's not a permanent magnet. Flender bar is a induced magnet. It's a soft iron. So as the Earth's magnetic field magnetizes the funnel or the derrick, in the same way it is going to magnetize the Flender bar. Okay. Clear हुआ बेटा?
Yes, sir. Yes, sir. Got it.
और इसके साथ एक और भी चीज देखो बेटा, हमने ये जो करेक्शन की है, we have corrected the magnetism of the funnel using a Flender bar, a soft iron. Now you see when we change the hemisphere, in the north hemisphere the lines were going down, so the top of the funnel was blue. But when you change the hemisphere and you go to the south hemisphere, the lines will be coming out. The top of the funnel will get a red polarity. And you see the beauty of the correction. We have done the correction with a soft iron bar, soft iron, vertical soft iron. And when you change the hemisphere, the pole on top of the Flender bar also changes automatically because it does not have any magnetism of its own. It gets magnetized by the field of the earth. So the way it magnetizes the funnel, the same way it will magnetize the corrector. And at every latitude and in each hemisphere, the correction is going to be compensated accordingly. So if you follow this principle of like cures like, it will compensate your correction anywhere the ship goes.
Yeah, that is correct. Sir,
Okay.
effect of latitude, how much it will affect sir, on the change of latitude? This B coefficient.
Okay, you have a question which has come like this?
No, sir, I saw in some explanation like when they are explaining coefficient B, so they are explaining what will happen on the change of latitude. If we have a change of latitude, then what all things will happen? Directive force or...
What I will do is, beta, I will send you a short note. I will put it on the WhatsApp group. Just read through that note. So then it will become clear the effect of latitude on coefficient B.
Okay, thank you.
Okay. Okay, all right. Great beta. Let's go into next coefficient, Charlie.
सर ये सर लास्ट में ये फॉर्मूला को कैसे यूज करना है सर, एक बार बता देंगे सर, वो नहीं समझा सर.
Which formula beta? Which formula?
सर
Deviation formula, A plus B sine cos C cos cos. ये वाला फॉर्मूला बेटा?
यस सर, यही वाला सर।
इसका कोई प्रैक्टिकल यूजेज नहीं आएगा बेटा, नो प्रैक्टिकल यूजेज, दिस इज ओनली फॉर अंडरस्टैंडिंग पर्पस.
Okay sir, okay sir.
Every coefficient, when you look at the definition, you can easily understand that coefficient if the formula is known to you. अभी जैसे मैं coefficient C कराऊंगा तो आप देखोगे जो इसकी definition है, once you know the formula, memorizing the definition becomes very very easy. That's the only purpose. This is not going to be used in any numerical.
Okay sir, okay. Thank you sir.
Okay. No. Now let's move on to our next coefficient, which is coefficient C. Coefficient C is the maximum value of the semicircular deviation, which varies as the cosine of the compass course. It is caused by the horizontal Athwartship component of the ship's magnetic field. Now, if you look at the definition carefully, you will understand and realize that this definition is very much similar to coefficient B. In fact, coefficient C is almost having the same properties as we discussed in coefficient B, with only one difference. Bravo and Charlie, both these coefficients are exactly similar with only one difference. Coefficient C is dependent upon or is related to the Athwartship component of the ship's magnetic field. The last coefficient which we discussed, that is coefficient B, it was dependent upon the fore and aft component of the ship's magnetic field. And coefficient C is dependent upon the Athwartship component of the ship's magnetic field. Exactly like coefficient B, which had two components, the coefficient C also has two components. Coefficient C comprises of permanent C as well as induced C. Moving ahead now. So moving on to permanent C. Permanent C is caused by the Q component of the ship's permanent magnetism. We have three components of the ship's permanent magnetism, that is P, Q and R. P component lies in the fore and aft direction, Q component lies in the Athwartship direction, and R component lies in the vertical direction or orientation. So this is caused by the Q component, that is the Athwartship component of the ship's permanent magnetism. Now, to understand it more clearly, let's assume that we have a ship which is built in a yard on a easterly heading. Now, if the ship is built on a easterly heading, the magnetic lines of force will be entering into the ship's hull from the starboard side. So because of that, the starboard side will acquire blue polarity and the magnetic lines of force will be leaving out or coming out of the port side of the ship. So it will acquire a permanent red pole on the port side and a permanent blue pole on the starboard side. If a ship is built on a westerly heading, for a vessel built on a westerly heading, it will have the poles in the opposite direction. That means you will have a blue pole on the port side of the ship where the lines of force will be entering, and you will have a red pole on the starboard side of the ship where the magnetic lines of force will be coming out. So we will now pick up one of these ships and see the effect of this permanent C on the compass. Let's now try to understand the deviation diagram for coefficient permanent C. We are considering a ship which is built on a easterly heading. Just now we saw that a ship which is built on a easterly heading has a blue pole on the starboard side and a red pole on the port side. So as you can see in this diagram, the ship has a blue pole on the starboard side. In all the diagrams you see on the starboard side there is a blue pole, and we have a red pole on the port side. In all the diagrams, you can see this red pole on the port side. Let's take the ship on the northerly heading first. Now, when the ship is on the northerly heading, we have the compass needle and these two poles affecting the compass needle. The blue pole is to the east of the compass needle. This blue attracts the red end of our compass needle and repels the blue end of our compass needle. Looking from top, the needle turns or swings clockwise, generating a easterly deviation. Similarly, you have a red pole on the port side of the ship, and this red pole generates a similar effect. It adds on to the effect. Red pole repels the red end of the compass needle and attracts the blue end of the compass needle. Looking from top, the needle turns clockwise, generating a easterly deviation. The deviation generated on the northerly heading is maximum because these poles are at right angles to the magnetic field of the Earth, or they are at right angles to the compass needle, generating maximum deviation. Now, on the southerly heading, the situation is exactly the reverse. The blue pole goes to west of the compass needle, and the red pole of the ship goes to east of the compass needle. This red pole to the east of the compass needle repels the red end of the needle, attracting the blue end. The needle swings anti-clockwise looking from top, generating a westerly deviation.
Sir ji.
Go ahead, beta.
Sir, echo aa raha hai.
Go ahead.
Sir, echo aa raha hai video audio mein.
Okay, just a minute. The blue pole, which is west of the compass needle, blue pole of the ship west of the compass needle, adds on to this effect. This blue attracts the red end of the compass needle, repelling the blue end. Needle turns anti-clockwise, looking from top, generating a westerly deviation. The westerly deviation generated on the south heading is also maximum because the ship's poles are at right angles to the compass needle, or they are at right angles to the magnetic field lines of the Earth. Now let's move on to the easterly heading. On the easterly heading, we see that the ship's poles are exactly in line with the compass needle. The red pole of the ship is exactly north of the compass needle. The blue pole of the ship is exactly south of the compass needle. Now, when the poles of the ship are exactly in line with the magnetic field of the Earth, they are not able to generate any deviation. So there is no deviation which is generated on easterly heading. And we have the exact situation on the westerly heading also. The only difference is blue pole of the ship goes to north of the compass needle, red pole of the ship goes to south of the compass needle. Again, they are falling exactly in line with the magnetic field of the Earth, generating no deviation. So no deviation is generated on westerly heading also. Go ahead, beta. Go ahead with your doubt. Any doubts up to here, beta?
नहीं सर, वो आपका जो माइक है ना, इट इज रिपीटिंग द वॉल्यूम, रिपीटिंग द व्हाटएवर ऑडियो इज बीइंग.
Is it still okay?
हाँ सर, तो एक बार जब वीडियो चलती है तो could you just try switching off your mic?
Okay, give me a minute, beta. I'll try it once again. On north and south heading, zero deviation on east and west headings. This tells us that this coefficient is proportional to cos of the compass course. Cos of 0 and -70 has zero magnitude.
Sir, same issue with your sound, sir.
Sir, your voice broken.
Okay, beta, hold on. Let me check. We now move on to the northeasterly heading. In the northeasterly heading, the red pole of the ship is northwest of the compass needle. This red pole repels the red end, attracts the blue end towards it. Looking from top, the compass needle swings clockwise, generating a easterly deviation. How is it, beta? Okay now?
Yes, sir. Okay, sir.
Okay, all right, great. The blue pole, which is to the southeast of the compass needle, adds to this effect. This blue attracts the red end towards it and repels the blue end of the compass needle away from it. Again, looking from top, the compass needle swings clockwise, generating a easterly deviation. But this easterly deviation is less than what was generated on the northerly heading. Because on northerly heading, the poles were at right angles to the magnetic field of the Earth, where they generate maximum deviation. On northeasterly heading, they are not at right angles, but at a 45-degree angle from the magnetic field of the Earth, so the deviation generated is also reduced. Now, if you look carefully on all the northerly headings, whether the ship is on northwest heading or north heading or northeast heading, easterly deviation is generated. And if you look carefully on all the southerly headings, a westerly deviation is generated. So this is also a semicircular deviation from 090 going up to 180 up to 270. The deviation has westerly name, and from 270 going up to 000 and 090 northwest and northeast quadrant, it has a easterly deviation. So this is a semicircular deviation. Now moving on to the effect of this permanent C on the directive force. If we consider the ship on a northerly or southerly heading, on north and south headings, we see that the poles of the ship, the blue pole and the red pole, are exactly east or west of the compass needle, and they do not affect the directive force at all. For affecting the directive force, the poles have to be north or south of the compass needle. So on northerly as well as southerly heading, there is no effect on the directive force. Let us take the ship on easterly and westerly heading. On easterly heading, we have the red pole of the ship north of the compass. But north of the compass, we have the blue pole of the Earth. So blue of the Earth and red pole of the ship, since they are of opposite names, there is a reduction in the directive force. Likewise, south of the compass needle, we have the blue pole of the ship and the red pole of the Earth. Being of opposite polarity, they reduce the directive force, and this reduction in the directive force is maximum on easterly heading because the poles are exactly north and south of the compass needle. When the poles are exactly north or south, they have the maximum effect on the directive force. Go ahead, beta. Go ahead with your doubt.
सर ये बहुत इकोज आ रहा है, क्लियर समझ नहीं आ रहा।
अच्छा, अभी भी इको आ रहा है बेटा?
यस यस, शुरू में एक्चुअली कम आ रहा है, धीरे धीरे इकोज बढ़ता जा रहा है।
Sir, I feel that whenever you are using the pointer, then only echo is coming. When you are stopping the presentation and moving the pointer, then echoes is completely vanishing.
Okay, all right, beta. Let me log out and log in again. Give me a minute. Is the echo still coming or okay now?
Okay, no, sir.
Okay, all right. If it repeats again, just raise your hand, beta. I will come to know. The coefficients are always corrected on the heading on which they produce maximum deviation. For the coefficients to produce or generate maximum deviation, it should be acting perpendicular to the compass needle or to the magnetic field of the Earth. Now in our case, you can see the maximum deviation is being generated on northerly heading and on the southerly heading. It is on north and south heading that the poles of the ship are at right angles to the magnetic compass. So this coefficient would be corrected on a northerly heading or on a southerly heading. Basic principle which is followed in correcting a compass is to cure like with like. That is, a permanent deviation is cured with permanent magnetism and induced deviation is cured with induced magnets. So in our case, this is being generated because of permanent magnetism of the ship. So we will be using a permanent magnet to correct coefficient permanent C or PC. So as we just now saw, cure like with like principle is used in the correction. PC, which is caused by ship's Athwartship horizontal permanent magnetic field, is therefore corrected using Athwartship permanent magnets placed horizontally. They are so placed as to produce a permanent magnetic field at the compass location which is exactly equal and opposite to that of the ship. Now in the diagram you see this ship. We are looking at the ship from the stern. You see we have a blue pole on the starboard end of the ship and we have a red pole on the port end of the ship. This was generating coefficient permanent C. Now on top you see this represents the binnacle of the magnetic compass, and in the binnacle we keep the corrector magnet. This small magnet on top is the corrector magnet which is placed. The holes are made in the binnacle in the Athwartship direction, and these magnets are placed in those holes, making sure that the ends of the corrector magnet are opposite to the ends of the ship's permanent magnetism in the Athwartship direction. Moving ahead now. The magnets which are used for correction are exactly similar to the ones which were used for correcting permanent B. So these Athwartship magnets are magnets of circular cross section which are 8 inches long and having 3 by 8 inch or 3 by 16 inch diameters. Two thicknesses are usually provided by the compass makers. In case a powerful magnet is required, then we will be using the 3 by 8 inch configuration, and in case we need a not very powerful magnet, a 3 by 16 inch diameter magnet can be used. Slots are provided in the binnacle below the compass and the magnets are placed 2 in a row side by side. This is exactly as we corrected the permanent B. Only difference was in permanent B the magnets were placed in the fore and aft direction. In correcting permanent C the magnets are placed in the Athwartship direction. Moving ahead now. Let's now move on to the second component of coefficient C, coefficient Charlie, which is induced C, in short known as IC. IC or induced C is caused by a horizontal Athwartship magnetic field due to the induced magnetism in the vertical soft iron to port or to starboard of the compass location. So you see in this case very similar to coefficient IB. IB was caused because of a vertical structure which is forward or aft of the compass, and IC is caused because of a vertical structure which is port or starboard of the compass. Practically, IC does not exist on a merchant vessel, as the vertical soft iron to port and starboard of the ship's center line, if it is there, is symmetrically placed. So practically you see coefficient induced C or IC is not present on most of the merchant vessels because number one, there is hardly any prominent vertical soft iron structure to port or to the starboard of the compass location. Forward or aft of the compass, we have substantial VSI, big VSI structures. It could be the mast, it could be a crane or a derrick kind of structure. But port and starboard of the compass location, we usually do not have a prominent vertical soft iron structure. So if that structure is not there, coefficient IC or induced C will not be generated. Moving ahead. This coefficient induced C or IC may be present on special type of ships where compass is placed off the center line. For example, in ships like aircraft carriers, you see in the aircraft carriers to provide space for the runway, the bridge is off-centered to starboard or to port, and because of this, the compass location is also not on the center line, but it is offset to either port or starboard. Now in such a case, you can see in the diagram, the compass is placed off-center and the ship's fore and aft centerline bulkhead acts as a vertical structure in this case, and the induced magnetism generated by this vertical soft iron to port or starboard of the compass does generate induced C. Moving ahead now. Let's now discuss the deviation generated because of coefficient IC induced C. We have assumed a ship which is having a vertical structure to starboard of the compass location. So you can see here we have a vertical structure to starboard of the compass location, and this is a soft iron structure, and we are assuming that the ship is somewhere in the northern hemisphere. Now we know that in the northern hemisphere the magnetic lines of force, they re-enter into the Earth's surface. So these magnetic lines of force will be entering from top of the vertical structure and will be going out from the bottom of the vertical structure. Now since the top of the vertical structure is close to the compass location, this is what affects our magnetic compass. And in this case, with the ship being in the northern hemisphere, magnetic lines of force entering from top of the vertical structure, they give a blue polarity to the top of VSI, and that is why you see in the diagram we have a single blue pole to the starboard of the compass. You can see the ship in any of the cardinal and intercardinal heading. The ship is shown here on 4 cardinal and 4 intercardinal headings, and in all these diagrams you will see a blue pole getting generated to starboard of the compass because of this vertical soft iron. If the same ship happens to go into the southern hemisphere, the polarity will change to a red pole. So that is how induced magnetism works. So let's now try to see the kind of deviation which this vertical soft iron structure generates. So let's assume the ship on a northerly heading first. Now with the ship on a northerly heading, you can see the compass needle represented by the red and blue poles arrow shown in the diagram. So this represents our compass needle, and we have a blue pole to the starboard of the compass needle, or to the east of the compass needle in this case. This blue pole attracts the red end or the north end of our magnetic compass needle, and at the same time this blue pole repels the blue end or the south end of our magnetic needle, thus generating easterly deviation. Now the deviation generated at this location is maximum. The reason for deviation being maximum is that this blue pole is at right angles to the compass needle, or it is at right angles to the Earth's magnetic field line. Whenever the disturbing pole, the blue pole or the red pole, is at right angles to the Earth's field or to the magnetic compass, it generates maximum deviation. So we have maximum easterly deviation when the ship is on a north heading. Now, since the pole is neither to the north of the compass nor to the south of the compass, it has no effect in the directive force. The directive force can be affected by this pole if it is north of the compass or south of the compass. But in this case, it is perfectly aligned to the east of the compass location, thus making no change in the directive force. Now, let's assume the ship on a easterly heading. So with the vessel on a easterly heading, this blue pole now comes exactly south of the compass needle. The blue pole is exactly south of the compass needle. Now this blue pole would try to repel the blue end of our compass needle. It is close to the blue end of our compass needle. It will try to repel it. And if this was the only force affecting our compass, the compass would have pointed towards south, because this blue pole will try to attract the red pole of the compass. But that is not the case. This pole is not able to generate any deviation at all, because the Earth's magnetic field, which is much more powerful as compared to this blue pole, keeps the compass pointing in the northerly direction. And the blue pole is not able to generate any kind of deviation. For generating deviation, the blue pole has to be at some angle to the magnetic lines of force. It has to be either east or west of the compass needle. So in this case, it is exactly aligned with the compass needle and as well as the magnetic lines of force, thus generating no deviation at all. Maximum deviation is generated when the disturbing pole or the disturbing force is at right angle to the compass needle, and no deviation is generated when the pole is aligned with the compass needle. So with the ship heading in the easterly direction, we have zero deviation, no deviation. In this location, the pole has an effect on the directive force. To the south of the compass needle, we have the red magnetic pole of the Earth, whereas this pole is having a blue polarity. So the polarity of this particular pole is opposite to the polarity of the Earth's pole in this direction, thus reducing the directive force at the compass location. Any doubts up to here, beta? Okay, great. Let's now move on to the condition where the ship is heading on a northeasterly direction. The vessel is heading in the northeasterly direction. Now this vertical soft iron structure is southeast of our compass needle. So being southeast of our compass needle, the blue pole repels the blue end of our compass needle, thus generating easterly deviation. So we still have easterly deviation, but this deviation is less than the deviation which was generated on the northerly heading. Northerly heading, maximum deviation was generated because the pole was at right angles to the compass needle, whereas when the vessel is heading in northeasterly direction, the pole is not at right angles to the compass needle. It is at a 45-degree angle to the compass needle. Being southeast of compass needle, it is at a 45-degree angle. Thus, it generates a easterly deviation, but it is lesser than the maximum deviation which was generated on northerly heading. Also, we can see its effect on the directive force now. The blue pole is southeast of the compass location. So the blue pole is having a southerly component, or it is south of our compass needle. So being south of the compass needle, it is opposite to the red pole of the earth, thus reducing the directive force. So the directive force is reduced at the compass location, but it is not the maximum reduction. Maximum reduction is occurring on easterly heading. So we have seen the deviation on these three headings, and you can appreciate now the deviation is proportional to cos of the compass course. Anotherly heading where the course is 0, 0, 0, cos of 0 is equal to 1, denoting maximum deviation, and we see maximum deviation is generated here. On easterly heading, when the course is 0, 9, 0, cos of 90 is 0, which converts into 0 deviation, and we can see here that 0 deviation is caused. So the deviation generated is proportional to cosine of the compass course, thus falling under coefficient C, and since it is generated by a vertical soft iron structure, it comes under the component of IC, or induced C. So you can now check the deviation generated on any of the other headings, and you will realize that all throughout the 360 degrees, it is proportional to cos of the compass course. So have a good look, beta. Let me know any doubts coming in. Very good, beta. Great. Let's move ahead. Let's now move on to the correction of coefficient IC, induced C. And first of all, let's refresh the correction procedure, the correction fundamentals. Coefficients are always corrected on the heading on which they produce maximum deviation. In this case, maximum deviation is generated on northerly or southerly heading, so the correction is made on one of these two headings. For the coefficient to cause maximum deviation, it should act perpendicular to the needle. So we have seen in the previous diagram that on northerly and southerly heading, the pole is at right angles to the compass needle, thus generating maximum deviation. Basic principle which is followed in correcting the compass is to cure like with like. That is, permanent deviation is cured with permanent magnets, and induced deviation is cured with a induced magnet. So this being a induced magnetism will be corrected using a induced magnet only. Moving ahead now. A normal merchant vessel does not have IC, therefore no correction is generally required. However, if the compass is badly placed, IC will be present. Now this is corrected using the same principle as induced B. Thus, a flinder bar can be placed port or starboard of the compass, opposite to the side on which the Athwartship vertical soft iron is predominant. Exactly the same thing was done in induced B also. We placed a flinder bar opposite to the funnel. So likewise in this case also we place a flinder bar which is opposite to the VSI structure to port or starboard of the compass location. Now one important thing to understand here is that if a merchant vessel has both the coefficient IB as well as IC together, we have a method with which both these coefficients can be corrected in one go. Instead of using two flinder bars, the correction can be done using only a single flinder bar, which will correct both these coefficients together, induced B as well as induced C. So how is this done? Let's see. A merchant vessel will definitely have induced B because of the funnel, the mast, vertical structure fore and aft of the compass will certainly be present, and it is corrected using a flunder bar forward or aft of the compass as required. If induced C is also present, then another flunder bar will be required to port or starboard of the compass opposite to the VSI. It is very much convenient to use only a single flunder bar and slew it. Slew basically means turning it from the fore and aft line to port or starboard of the compass. So the fundamental of this correction is that we take a single flunder bar, instead of placing it forward of the compass, we slew it or we turn it in a direction which is opposite to the resultant of IB as well as IC. So once it is placed in that way, this is able to correct this flunder bar, single flunder bar is able to correct both these coefficients together. Now, the first question which arises in our mind is, how do we determine the angle by which the flunder bar should be slewed? This is also called as the slew angle. And also, we need to know what is the direction in which the flunder bar should be slewed, to clockwise or to anti-clockwise. These are the two things which we need to know before we correct a IB and IC combination using a single flunder bar. Now for this, let us understand it using one example. Let's assume that in the diagram, you can see the laser pointer. In the diagram, this is the compass location where the laser pointer is right now. Now we have a funnel which is aft of the compass needle. The ship is right now, let's assume the ship is heading north 000. So we have the flunder bar at this particular location. So this flunder bar is generating IB or induced B component. So this vector represents the IB component. Now let's also assume that on this particular ship, there is a vertical soft iron structure to starboard of the compass, and that structure is present here at this particular location. Now this structure is going to cause induced C, and this vector where the laser pointer is right now, this vector represents the component or coefficient IC. Now if we take a resultant of these two coefficients, the resultant can be easily obtained by making a parallelogram. So if you make a parallelogram using these two IB and IC vectors, the diagonal of the parallelogram, this diagonal of the parallelogram gives us the resultant of these two forces. Now we can find out the magnitude of this resultant by using the Pythagoras theorem. It will be equal to the base square plus the perpendicular square under root. That is IC square plus IB square under root will give us the magnitude of this effect, which is the resultant effect of IB and IC. Also, we can easily find out this angle. This is the angle between the fore and aft line. This is the fore and aft line and the resultant of IB and IC. In the diagram, we have represented it by capital M, and this particular angle, capital M, basically gives us our slew angle. We can easily find out this angle M. Now we know tangent theta is equal to perpendicular upon base. So tangent of this angle M will be equal to the perpendicular. You can see the perpendicular is basically the IC component, and the base is the IB component. So you see tangent of this angle will be equal to IC upon IB. So you can see the formula here. Tangent of the slew angle is equal to IC upon IB. So if we know the magnitude of IB and we know the magnitude of IC, then we can easily calculate the slew angle. The slew angle, once calculated, gives us the information how much turning or slew is required for the flunder bar. Now the flunder bar has to be placed in a direction which is opposite to the resultant of these two forces. So opposite to the resultant, we place the flunder bar somewhere here in this direction. The magnitude of the flunder bar or the length of the flunder bar is decided by the magnitude of the resultant, and the slew angle is this angle M, which we have calculated using the formula tan of slew angle is equal to IC upon IP. Now, when we make the combined correction for IC and IB, we have to also find out what is the heading on which the ship should be when the correction is made. Now, coefficients are always corrected on a heading on which they produce maximum deviation. For the resultant of IC and IB to cause maximum deviation, it should act perpendicular to the needle. The compass needle always lies in the north-south direction. So for the force to act perpendicular to this direction, this resultant vector should be acting in the easterly direction. If this resultant vector is in the easterly direction, it will be acting at right angles to the compass needle, generating maximum deviation. Now for this resultant to lie in the easterly direction, it has to swing by an angle, or the vessel has to swing by an angle equal to 90 minus m. You can see the laser pointer. This is the angle by which the vessel has to be swung to the port side so that the resultant is acting in the easterly direction, which is perpendicular to the compass needle heading north and south, or aligned in the north and south direction, generating maximum deviation. So swing the ship 90 minus m degrees to port for the combined correction. Now another option which is available to us is if this resultant vector acts in the westerly direction. If it acts in the westerly direction, even then it will be acting at right angles to the compass needle, and this will happen when the ship is on a reciprocal heading to the initial one. If you swing the ship 90 minus m to port, we obtain one of the headings, and also on a heading reciprocal to that, 180 degrees apart from that, you will see that this is the second option available to us to correct IB and IC together. So did you understand that, beta? Any doubts coming in?
सर एग्जाम में अभी जैसे ये आईबी एंड आईसी का टुगेदर ये करने के लिए एग्जाम में कैसे ये क्वेश्चन पूछते हैं सर इसका?
ओके बेटा, दो तरीके से पूछा जा सकता है बेटा. एक तो थ्योरी क्वेश्चन आपको आ सकता है, हाउ विल यू करेक्ट आईबी एंड आईसी टुगेदर. उसके लिए एग्जैक्टली जो डायग्राम आप अभी देख रहे हो, यही डायग्राम आपको बनानी है और जैसे ये एक्सप्लेनेशन दे रखी है ऐसे ही एक्सप्लेन करना है. दिस इज वन वे द क्वेश्चन कैन बी आस्क्ड. सो एक तो ये तरीका है बेटा जिससे सीधा सीधा क्वेश्चन आएगा, correct IB and IC together, explain the procedure. So make this diagram and explain these 3 points. Okay, this is one way. Okay, now the second method by which they can ask you is by way of a simple numerical question. वो आपको इसी fundamental पे एक numerical question दे सकते हैं बेटा, and in that numerical question they can actually ask you find the course which the ship should steer for correction IB and IC. So I will show you how a numerical question is made like that. वो मैं अभी आपको दिखाता हूँ बेटा. So any more doubts up to here? Go ahead beta.
Sir, like we get by calculation we'll get 90 minus m by u, and we
Right.
swing the ship in that direction. Then what we will do with the flinder bars is for the Athwartship and for the forward and up direction.
You mean to say, beta, what will be the length of the flinder bar? Is that the question?
No, sir. Like we swing our ship 90 minus m, and
Right.
for the forward and aft correction, our cylinder bars is like from forward and aft. The predominant is the funnel aft, so we have placed in forward. And like if the structure is starboard side of the compass, we place cylinder bar on the port side to compensate that. So
Right.
how we will make correction with one cylinder bar?
Okay, बेटा. Okay. I'll explain you once again. देखो बेटा, हमारी जो फनल है वो तो कंपस के या बिनैकल के बिल्कुल आफ्ट में है. अगर हमें सिर्फ फनल की करेक्शन करनी होती तो हम फ्लिंडर बार को बिनैकल के फॉरवर्ड में लगा देते, राइट? राइट.
यस सर.
अब यहाँ पे एक वर्टिकल स्ट्रक्चर है टू द स्टारबोर्ड साइड ऑफ द फनल. अगर हमें सिर्फ ये वर्टिकल स्ट्रक्चर की करेक्शन करनी होती तो हम एक छोटी फ्लिंडर बार बिनैकल के पोर्ट साइड में लगा देते, ऑपोजिट टू द वर्टिकल स्ट्रक्चर, राइट? 2 फ्लिंडर बार हम लगाते, एक बिनैकल के फॉरवर्ड में, कंपस के फॉरवर्ड में, और एक कंपस के पोर्ट साइड में. अब हमने क्या किया है बेटा, हमने इन दोनों फ्लिंडर बार की जगह पे एक सिंगल फ्लिंडर बार को लगाया है, और वो सिंगल फ्लिंडर बार को हमने IB और IC के रिजल्टेंट के ऑपोजिट लगा दिया है. तो आप इस तरह से सोचो कि एक फ्लिंडर बार अगर कंपस के फॉरवर्ड में है, दूसरी फ्लिंडर बार कंपस के पोर्ट साइड में है, तो कहीं ना कहीं बिटवीन द फॉरवर्ड ऑफ द कंपस and port side of the compass, somewhere in between you will have the resultant of these two flinder bars. तो ये 2 फ्लिंडर बार लगाने की जगह हमने एक सिंगल बड़ी वाली फ्लिंडर बार लगा दी जो इन दोनों इफेक्ट को कैंसिल कर रही है, राइट बेटा? The fundamental is something like go ahead.
First we will swing the ship 90 minus m. Whatever the cost.
No. सबसे पहली चीज बेटा, स्विंग तो बाद में करेंगे. सबसे पहली चीज तो हम ये एंगल m को कैलकुलेट करेंगे, बिकॉज एंगल m हमें बताएगा कि फ्लिंडर बार को फिट किस लोकेशन में करना है. जब एंगल m आएगा तो उसके बाद कंपस एडजस्टर सबसे पहले तो शिप की फोर एंड आफ्ट लाइन के रेस्पेक्ट में फ्लिंडर बार को बिनैकल में फिट कर देगा. ही हैज टू फिट इट विद स्क्रूज. तो वो फ्लिंडर बार को स्क्रू के साथ इस डायरेक्शन में पहले फिट कर देगा. अब एक बार उसने फिट कर दिया, अब उसे इस फ्लिंडर बार को अपनी कंपस के ईस्ट में या वेस्ट में लेके जाना है. सो वंस ही हैज फिटेड द फ्लिंडर बार, ही विल नाउ स्विंग द शिप. आप इसे 90 माइनस m पोर्ट में स्विंग करोगे तो फ्लिंडर बार आपके वेस्ट में आ जाएगी, एग्जैक्टली वेस्ट में आ जाएगी. ओके, सो देन he takes the ship, swings the ship 90 minus m to port. Flinder bar comes to west of the compass location. Resultant will come to east of the compass location, and that is where he will correct it. समझ गए बेटा? डाउट है अभी भी?
To place the flinder bar, we will correct the IB and IC. Once we will place the flinder bar opposite the resultant, that time only the correction will be corrected.
हाँ, that's right बेटा. हमें
सर ये न्यूमेरिकल जो आता है उसमें IB एंड IC का वैल्यू दिया हुआ रहता है क्या, कि आप मतलब फिर हम लोग को रिजल्ट
मैं अभी दिखाता हूँ आपको बेटा. आई विल शो यू द न्यूमेरिकल. ओके, आप पहला वाला डाउट क्लियर हुआ बेटा या अभी भी डाउट है?
only doubt is that once we will place the flinder bar opposite to the resultant, that time only we can correct the IB and IC.
No, that time you cannot correct it beta. For correction, the coefficients are corrected on that heading where they generate maximum deviation. अभी हमारा शिप नॉर्थ हेडिंग पे है. आप फ्लिंडर बार को यहाँ फिट तो कर सकते हो, खाली केसिंग को फिट कर रहे हो आप, लेकिन उसमें जो सॉफ्ट आयरन डालोगे वो तब डालोगे जब आपका रिजल्टेंट नॉर्थ साउथ डायरेक्शन के परपेंडिकुलर एक्ट करेगा. दैट मीन्स व्हेन द रिजल्टेंट इज ईस्ट और वेस्ट ऑफ द कंपास और बिनेकल.
Okay, sir. In which direction where the maximum deviation occurs, that direction we will put the characters in the filter bar.
Yes, that is correct. Okay. अभी मैं आपको एक न्यूमेरिकल क्वेश्चन दिखाता हूं which comes in the exam based on this. So उससे आपको जो है और क्लैरिटी मिलेगी.
Excuse me.
Go ahead, बेटा.
Sir, could you please explain this 90 minus m part?
Okay. How did we get 90 minus m?
Yes.
Okay. बेटा एंगल m तो आपने निकाल लिया. एंगल m ओके.
Yes.
Angle m is okay. Now you see IB is acting exactly to the south of the compass needle or to the aft of the ship. IC is acting to the starboard side. Now the total angle between IC and IB is 90 degrees. Angle between right astern and starboard beam, right?
Yes.
So this yellow color angle has to be 90 minus m. Total angle is 90. So yellow angle has to be 90 minus m. So ये तो था बेटा कि angle 90 minus m कैसे आया. That is one thing. Okay.
Okay.
अब आपका डाउट ये भी है क्या कि हम शिप को 90 माइनस एम ही क्यों स्विंग कर रहे हैं?
Yes, sir. That's it.
ओके. सुनो ध्यान से बेटा. आईबी और आईसी का जो रिजल्टेंट है, दैट रिजल्टेंट इज इन दिस डायरेक्शन इन विच यू सी दिस ग्रीन कलर डायगोनल. दिस इज द रिजल्टेंट ऑफ आईबी एंड आईसी. करेक्ट?
Yes.
नाउ फॉर एनी फोर्स टू जनरेट मैक्सिमम डेविएशन, हमने अभी सारी डेविएशन डायग्राम्स की हैं अल्फा ब्रेवो चार्ली की. मैक्सिमम डेविएशन अकर्स व्हेन द फोर्स एक्ट्स इन द ईस्टर्ली और वेस्टर्ली डायरेक्शन. तो यही रिजल्टेंट मैक्सिमम डेविएशन कब जनरेट करेगा? व्हेन इट इज एक्टिंग इन द ईस्टर्ली और वेस्टर्ली डायरेक्शन. अब अगर इस रिजल्टेंट को हमें ईस्टर्ली या वेस्टर्ली डायरेक्शन में लेके जाना है, ईस्टर्ली डायरेक्शन में लेके जाने के लिए यू हैव टू टर्न दिस रिजल्टेंट बाय दिस येलो कलर एंगल. अब इसको येलो कलर एंगल के जितना टर्न कैसे करवाएंगे बेटा? आईबी और आईसी तो फिट है जहाज पे, फनल भी फिटेड है, इट इज वेल्डेड, वर्टिकल स्ट्रक्चर भी फिक्स्ड है जहाज पे. तो हम अपने शिप को स्विंग करेंगे टू द पोर्ट साइड. कितना स्विंग करेंगे? 90 माइनस एम एंगल स्विंग करेंगे. जब आप ये पूरे शिप को 90 माइनस एम एंगल स्विंग करते हो तो जो ये रिजल्टेंट है, दिस रिजल्टेंट विल कम ईस्ट ऑफ द कंपास and that is the place where it will generate maximum deviation. Compass needle तो north ही point करेगी. It will not change with the ship swinging. Right बेटा?
Right, sir. Understand.
Okay, great. अब अगर और भी कोई डाउट है, let us look at the numerical. I hope with the numerical it will bring more clarity. Let's go. We move on to the next question. The question says, on board your vessel, you have noticed that the Flinders bar is attached to the binnacle in a relative slewed direction. That is 015 degrees instead of usual direction of ship's head. Part A of the question asks, analyze and discuss the reason for such an arrangement. And part B asks, what would have been the ship's heading on which the maximum deviation occurred prior to the Flinders bar correction? Go ahead, beta. Go ahead with your doubt, beta. Dheeraj, any doubts? Okay, all right. Let's move ahead. So let us first try to understand the meaning of the question. Let's make a diagram of a ship. You can see a particular ship here. We have shown the binnacle. We have shown the fore and aft line. You can see this dotted line here, the fore and aft line. And we have also shown the Athwartship line here to have a sense of directions. Now the question says the flinder bar is attached to the binnacle in a relative slewed direction of 015 degrees. Now the 015 degrees is basically the relative direction of the flinder bar with respect to the ship's head. So from the ship's head, if you go 15 degrees, let me show you here in the diagram. You can see from the ship's head, if we go 15 degrees, the relative bearings are measured clockwise from the ship's head. So if you go to this 15 degrees direction, this is where the flinder bar lies. You can see this yellow color flinder bar shown in the diagram now. So first part of the question says, analyze and discuss the reason for such an arrangement. Now on a usual ship, the flinder bar opposes the vertical soft iron present on the ship. On a normal merchant vessel, the main vertical soft iron, most predominant vertical soft iron which we have is the funnel. The funnel is usually exactly aft of the compass. So to compensate the funnel's effect, the flinder bar is fixed up just forward of the compass. But in this case, the flinder bar is slewed 15 degrees. Now that means that the magnetic field generated because of vertical soft iron is not aft of the compass. The magnetic field which is generated must be opposite to the direction where the flinder bar is. So that means that whatever magnetic field is there on the ship because of vertical soft iron will have a resultant direction opposite to where the flinder bar is. So as you can see, this red color arrow shows us the direction of the resultant magnetic field caused because of vertical soft iron. So if the vertical soft iron causes a field in this direction, in the direction of the red arrow, the flinder bar is fitted, the yellow color round represents the flinder bar, will cancel its effect and the compass will be corrected. Now, how can we have the resultant in this particular direction? Now we are aware that exactly aft of the binnacle, we will have the funnel. So you can see the funnel now coming up in the diagram. So funnel will be exactly aft of the binnacle. The resultant is slightly towards the port quarter. So that simply tells us that there has to be a vertical structure on port side of the compass or port side of the binnacle. You can see a vertical structure now coming up towards the port side of the binnacle. So the resultant of this vertical structure and the funnel falls in the direction of the red arrow, and this resultant is what is our flinder bar correcting. So that brings us to the answer of the first part of the question. The first part answer basically is that the flinder bar is slewed when IC, induced C, is also present along with IB, induced B. So that tells us that there is a vertical structure on the port side of the compass. Any vertical structure to port or starboard of the compass generates induced C. Beta, up to here is clear? Okay, great. Let's move ahead. So this is the analysis for the first part of the question. Now the second part of the question says, what would have been the ship's heading on which the maximum deviation occurred prior to the flinder bar correction? The meaning of this question, part B, is that we have seen that the resultant of IB and IC, funnel and the vertical structure, lies in this particular direction, in the direction of the red arrow. Now, what is the heading on which this resultant would cause maximum deviation? Now, for any magnetic force to cause maximum deviation, it should act at right angles to the magnetic needle. You can see it here also. Maximum deviation because of any force or magnetic field occurs when that force, in our case the resultant of IB and IC, which is the red represented by red arrow. So maximum deviation occurs when this resultant acts at right angles to the compass needle or at right angles to the magnetic lines of force which run in the north-south direction. You can also represent it in this way, that the maximum deviation would occur when the resultant should lie exactly east or exactly west of the compass. So if we take the ship on such a heading that this resultant goes to exactly east or west of the compass, that is the heading on which the maximum deviation would occur. So let us see that now. The first option of bringing this resultant to port or starboard of the compass is that if the resultant moves in the direction of the yellow arrow by this much of an angle, it would come exactly west of the compass needle. Now the angle represented by this yellow arrow is 75 degrees. You see the flinder bar was moved 15 degrees. So the remaining angle between the stern of the ship and the port beam of the ship is 75 degrees. So the resultant would come in direction west of the compass if we swing by 75 degrees in the clockwise direction. That basically means that if the ship alters its course to starboard by 75 degrees, you can see this green color arrow representing a 75 degree starboard alteration. That is the heading on which the resultant will be at right angles to the compass needle, right angles to the magnetic lines of force, and it will generate maximum deviation. And this heading will be 075 degrees. So this is one option. Now there is one more possibility of bringing the resultant to east or west of the compass. Instead of bringing it to west of the compass, we can also bring it to the east of the compass. Now to bring the resultant east of the compass, the resultant has to move in the direction of this new arrow, yellow color arrow now, which represents 105 degrees. So if the ship changes its heading or swings in the anti-clockwise direction by 105 degrees, this resultant is going to come exactly east of the compass, exactly east of the binnacle. And that tells us that if we do a alteration of 105 degrees to port represented by the red color arrow, if we do a alteration of 105 degrees to port, the resultant would be exactly east of the compass needle at right angles to the magnetic lines of force, generating maximum deviation. Now, if you swing 105 degrees to port, the heading will be 255 degrees. So the second heading is 255 degrees. If the ship heads on 255 degrees, resultant will be exactly east of the compass, generating maximum deviation. So go ahead with your doubts now, beta.
Sir, why did we take only northerly heading?
In the beginning,
Yes, sir.
you can take any heading, beta. You can start with any heading. Starting with northerly heading, make it look very, very simple. But if you want, you can go on any other heading and do this. It will be slightly complicated, but you will still get the same answer.
Okay, sir.
Sir, how it became 2 to 5 degrees, sir?
Ask again, beta.
Sir, you said 2 to 5 degree.
255 degrees, beta. Not 2 to 5. 255.
How, sir?
ओके बेटा, आप ये रेड कलर का एरो देख रहे हो, इसमें 105 डिग्री का एंगल हमें स्विंग करना है. इफ द शिप इज हेडिंग नॉर्थ एंड यू स्विंग टू पोर्ट बाय 105 डिग्रीज, तो आप कौन सी हेडिंग पे पहुंचोगे?
On the port side 255, on the starboard side 075.
Exactly, beta. That's right. These two are the headings which are our answers. Clear, beta? Any more doubts coming in?
सर ये इसमें पार्ट 1 में सर आईबी एंड आईसी कौन सा है, ये ये कैलकुलेशन जैसे बताया वो तो समझ में आ गया, बस आईबी एंड आईसी कौन सा है?
Ask again, beta. IB and IC कौन सा है? Meaning?
For resultant in question sir, IB and IC both have to present sir.
Yeah, that's right. IB and IC दोनों present है बेटा. आपका डाउट किस में आ रहा है?
Which one is IC sir?
Which one is IC? Okay. बेटा ये जो vertical structure देख रहे हो ना आप, which is on the port beam, ये vertical structure जो है IC को generate कर रहा है. This is generating a IC force.
Okay sir.
The funnel is generating IB, the vertical structure is generating IC, और इन दोनों का जो रिजल्टेंट है that is represented by the red color arrow. ये जो vertical structure है ये बहुत छोटा है, इसीलिए रिजल्टेंट को फनल से बहुत ज़्यादा दूर नहीं लेके जा पाया. अगर ये वर्टिकल स्ट्रक्चर एग्जैक्टली फनल के साइज का हो जाए तो जो रिजल्टेंट है वो एग्जैक्टली 45 डिग्रीज के बीच में आ जाएगा.
ओके सर. तो ओके सर.
ओके
Sir, funnel ka to we know that it will be aft of the binnacle. This vertical structure on the port, is it like not necessarily that it will always be like on the 90 degree from the funnel it is making? I mean, how is it, sir? If it is not exactly on the port, then the angle will change, na sir?
Okay, all right. So basically you are saying कि अगर ये vertical structure exactly port beam पे ना हो, it is somewhere in between. Let us say it is on somewhere on the port bow. Okay, तो in that case तो इसका effect जो है वो change हो जाएगा. Yes, that is possible. ये जो vertical structure है कहीं पर भी हो सकता है बेटा, and इसका effect भी change हो जाएगा. That's also true. इसे हम accommodate कैसे करेंगे? बेटा अगर ये exactly port beam पे नहीं भी है और ये थोड़ा आगे between the bow and the beam कहीं पे चला जाता है या क्वार्टर में कहीं पे आ जाता है, तो हम इसके इफेक्ट को दो कोफिशिएंट्स में डिवाइड कर देंगे. वन विल बी द फोर एंड आफ्ट कोफिशिएंट, अनदर विल बी द ऑथवर्डशिप कोफिशिएंट. जो फोर एंड आफ्ट कोफिशिएंट है वो फनल के जो इफेक्ट है उसको या तो ऐड ऑन करेगा या उसको रिड्यूस कर देगा, और जो ऑथवर्डशिप वाला कंपोनेंट है वो आईसी जनरेट करेगा. सो देन वी विल हैव टू ब्रेक इट अप.
Sir, वो point समझ में आ गया, like, but for examination purpose, when we are showing, we have to always show it on the port or starboard beam. Is that correct?
Exactly बेटा, exactly. क्योंकि आप अगर आंसर में इसे इन बिटवीन ले जाओगे तो आपका आंसर बहुत कॉम्प्लिकेटेड हो जाएगा. तो दैट इज वाई इंटेंशनली हम इसे इन बिटवीन में लेके नहीं जाते हैं, हम इसको ऑथवर्डशिप में ही रखते हैं. बिकॉज आईसी की जो मेन डेफिनेशन है उसमें जो सबसे यूजुअल लोकेशन जहां पे आईसी बेस्ट एक्सप्लेन होता है दैट इज एग्जैक्टली ईस्ट और वेस्ट ऑफ द कंपास.
राइट सर.
ओके, आप अगर इसे इन बिटवीन ले जाओगे तो हो तो सकता है, पॉसिबिलिटी है, लेकिन आप जानबूझ के अपना आंसर कॉम्प्लिकेट क्यों करना चाहते हो?
जी सर, जी सर.
ओके, एंड उससे कुछ ज्यादा बेनिफिट भी नहीं हो रहा. इट इज नॉट दैट वी विल बी एबल टू एक्सप्लेन सम एक्स्ट्रा फैक्टर. जो आप उसे जितना बीम से आगे पीछे लेके जाओगे इट विल ईदर एड ऑन टू द इफेक्ट ऑफ फनल और इट विल बी डिमिनिशिंग और काउंटरएक्टिंग द इफेक्ट ऑफ द फनल. उससे सिर्फ यही फर्क आएगा. अल्टीमेटली जो आईसी जनरेट करेगा वो तो इसका ऑथवर्डशिप कंपोनेंट ही होगा.
Right, sir. Just I asked because practically, okay, funnel is in the aft, but vertical structure can be anywhere. So that's why I was asking.
Right, that's right, beta. That's right. अच्छा, अब मैं आपको एक और एग्जांपल भी देता हूँ. If you have a twin propeller ship, तो जो twin propeller ship होता है उसमें दो funnels होती हैं. One of the funnel is on starboard quarter, another one is on port quarter. अगर ये दो funnel भी आ जाएंगी तो भी इन दोनों का जो रिजल्टेंट है वो एग्जैक्टली आफ्ट ऑफ द कंपास ही आने वाला है. ओके, उन दोनों का जो ऑथवर्डशिप कंपोनेंट है दैट इज गोइंग टू कैंसल आउट and ultimately you will be having the flinder bar which is exactly forward of the binnacle. आप दो flinder bar नहीं लगाओगे वहां पे, one to the port bow, another to the starboard bow. You will be fitting only a single flinder bar exactly forward of the binnacle, which will cancel the effect of both the funnels.
Understood, sir.
Okay, great. Very good, beta. So this is another 25 marks question which can come in your exams. This diagram and the explanation will do the job. Great, beta. So that completes coefficient Charlie. So I'm closing down the presentation now. आगे चलें आगे delta.
Yes, sir.
Okay, all right, great. So delta also very, very important and interesting coefficient. So let's see delta. Our next coefficient now is coefficient D, coefficient delta. Coefficient D is the maximum value of quadrantal deviation. Now this is the first difference which you see in this particular deviation. It is a quadrantal deviation. Coefficient Bravo and Charlie which we saw were semicircular deviation. This one is a quadrantal deviation, meaning every quadrant or every 90 degrees it changes its sign from east to west or west to east. And it varies proportional to sine of twice the compass course or sine of 2 into compass course. It is caused by a horizontal field due to induced magnetism in horizontal soft iron situated symmetrically about a 4.5 line through the compass. Now this coefficient is entirely generated by induced magnetism. There is no contribution of permanent magnetism in this coefficient. It is generated only by induced magnetism. We have seen induced magnetism was responsible for coefficient A also, but in that case, it was not symmetrical soft iron. It was unsymmetrical soft iron. If it was present forward of the compass, it was not present aft. If it was present on port side of the compass, it was absent on the starboard side. Whereas in this coefficient, you see it is situated symmetrically about a 4.5 line through the compass. The induced magnetism also resulted in IB and IC, but in both these cases, we had the vertical soft iron, forward or aft or port or starboard of the compass. In this case, it is not the vertical soft iron, but the horizontal soft iron which generates coefficient delta. Moving ahead now. Now let's go into the generation or the cause of the coefficient D. Generally, HSI, horizontal soft iron structure on merchant ships are transverse beams and fore and aft longitudinals or girders. Now, out of these two, the transverse beams are much more in number. they are present in the length profile of the ship, which is much more as compared to the breadth profile of the ship. The fore and aft longitudinal are present in the breadth profile. So transverse beams are much more in number as compared to the longitudinals. And also the ends of the transverse beams are much closer to the compass, making their effect much more predominant. Now the first thing to appreciate here is that if we have a transverse beam and if we have a fore and aft longitudinal exactly similarly placed about a compass having the same size, then they are going to cancel out the effect of each other. If they are perfectly balanced, equal to each other, they are going to cancel out each other. Now that is not the case. The transverse beams are much more in number, and secondly their ends are closer to the compass location. The ends of the fore and aft longitudinal are close to the bow and stern of the ship, which are far away from the compass location, whereas the beam stretch over the entire length of the ship and the ends of the beam are closer to the compass location as compared to the longitudinals. So number one, the beams are much more in number, and number two, their ends are closer. So thus making the effect of the Athwartship beam or transverse beam much more predominant as compared to a fore and aft longitudinal. So in our example, when we understand the deviation generated by coefficient D, we will be assuming one Athwartship beam, a horizontal soft iron, and getting or understanding the deviation from there. Let's now analyze the deviation diagram for coefficient D. So we have a ship here, and in this ship we have represented one Athwartship beam. As we just discussed that their effect is much more predominant as compared to the longitudinal. So we are assuming a Athwartship beam here on the ship. We have the compass needle. So you can see the red end of the compass needle pointing towards north and the blue end of the compass needle pointing towards the south direction. So let's now first concentrate on the northerly heading. The vessel is on a northerly heading in this diagram. Now when the ship is heading north, this Athwartship beam is at right angles to the magnetic field lines of the earth. The magnetic field lines are running from south to north, and this beam is lying in the east-west direction, perpendicular to the earth's magnetic field. Now since it is perpendicular, there is no induction or almost zero induction which happens on the beam. If there is no induction, no poles are generated, and if there are no poles, no deviation is generated. So the deviation generated on northerly heading is 0. Let's now take the ship on a easterly heading. So in this part of the diagram, you see the vessel heading in a easterly direction. Now with the ship heading on a easterly direction, this Athwartship beam is now perfectly aligned with the magnetic field of the earth. Since it is perfectly aligned, it will have the maximum induction caused because of the earth's magnetic field. The magnetic field lines will be entering from the south end or the starboard end of the beam, and they will be coming out from the north end or the port beam end of the Athwartship beam. The magnetic lines of force entering from south generate a blue pole. So we have a blue pole south of the compass needle, and we have a red pole north of the compass needle. Now these blue and red poles are exactly south and north of the compass needle. Being exactly aligned with the compass needle, they are not able to generate any deviation at all. Because for generating a deviation, the pole has to be at some angle to the magnetic field line or to the compass needle. In this case, it is perfectly aligned. Even though the poles are most powerful in this case, they are still not able to generate any deviation because these are aligned with the compass needle. So the deviation generated is again nil. Zero deviation is generated. Now let's take the ship on a northeasterly heading. Now with the vessel on a northeasterly heading, you see the Athwartship beam is partially aligned with the magnetic field of the Earth. It is at a 45-degree angle to the Earth's magnetic field. Now being partially aligned, the poles which are generated, they are partially powerful. They are not at their maximum power. They have partial power. But at the same time, these poles are at a 45-degree angle to the compass needle. Thus, they are able to generate a deviation here. The red pole which you see, which is on the port side of the ship, this red pole is towards the northwest of the compass needle. And this red pole repels the red pole of our compass needle, thus generating a easterly deviation. Likewise, if you pay your attention to the blue pole is southeast of the compass needle, and this blue pole repels the blue end of the compass needle, thus assisting in generating easterly deviation. So easterly deviation is generated in this case with the vessel heading in the northeasterly direction. Now this deviation which is generated here is the maximum easterly deviation. Why it is maximum? You can easily understand it. If the vessel changes its heading and moves toward the northerly heading, as it moves toward the northerly heading, you will see that the Athwartship beam is lesser aligned with the magnetic field of the Earth. It is slowly approaching a 90-degree angle to the Earth's magnetic field line, and thus the power of these poles which are generated keeps on reducing. The Athwartship beam angle to the magnetic field line keeps on increasing, thus reducing the induction and the poles becoming weaker and weaker. Because of the poles becoming weaker, the deviation keeps on reducing. Now, if the vessel swings to the starboard side and tries to approach the easterly direction, the poles are becoming stronger, but these poles are now coming in line with the magnetic needle. Now, as they come in line with the magnetic needle, they are not able to generate that much deviation, and the deviation starts to decrease. So maximum deviation is caused on the northeasterly heading, and zero deviation is caused on northerly heading as well as easterly heading. Now you can appreciate here the deviation is proportional to sine of twice the compass course. When the heading is 0, 2 into 0 is 0 again, sine of 0 is 0, therefore 0 deviation. When the heading is 45 degrees, 2 into 45 is 90, sine of 90 is 1, which is the maximum value, generating maximum deviation here. And when the vessel is heading in the easterly direction, heading is 90, 2 into 90 is 180. Sine of 180 is again 0, thus giving us a 0 deviation. So two things which we realize here. One, the deviation is proportional to sine of twice the compass course. Second, the deviation is quadrantal. You see, over one quadrant, it was 0 on the northerly heading, became maximum easterly on the northeast heading, and became 0 again on the easterly heading. Going further, if the ship swings to a southeasterly direction, we will see here that the deviation which is generated is of opposite name now. We have a westerly deviation generated here. So you can see these four quadrants showing the deviation generated, and it tells us that this is a quadrantal deviation. Now the same principle can be applied to any of the other headings, and you can appreciate the deviation being generated proportional to sine of twice the compass course. Now another important thing here is that the directive force in this case is never increased on any heading. You can check all the headings. The directive force is not affected on some of the headings. Yeah, like you see on northerly heading, there is no effect on the directive force. Whereas on northeasterly, easterly and southeasterly headings, the directive force is decreased. So why is this decreased? This is decreased because the blue end of the beam is aligned south of the compass needle, where we have the red end of the earth. Since the pole of the beam is opposite in direction or opposite in polarity to the pole of the earth, it reduces the directive force. Any doubts coming in this beta? Very good beta, great. Let's move ahead. Let us now see the correction of coefficient D. Coefficients are always corrected on the heading on which they produce maximum deviation. In this case, maximum deviation is generated on intercardinal headings, northeast, southeast, southwest and northwest. So for coefficient D, the correction can be made on any of the intercardinal headings. Basic principle followed in correcting a compass is to cure like with like. That is, permanent deviation is cured with permanent magnets and induced deviation is cured with induced magnetism. In the case of coefficient D, since it is generated because of soft iron structures because of induced magnetism, the correction is also done using a soft iron corrector. Moving ahead now. Let's now try to understand the coefficient D correction offered by the soft iron spheres. So let's have the ship in our diagram. You see the ship heading on a northeasterly direction. So why is the ship heading in the northeasterly direction? That's because all the coefficients are corrected on the heading where they are the strongest. So we know coefficient D is the strongest on intercardinal headings. That's why we have chosen a intercardinal heading, and that is northeast. Let's now show the magnetic compass on our ship. You can see the compass coming up. The compass needle is visible on the screen now. The north end of the compass needle having red polarity and the south end of the compass needle having the blue polarity. Let's now show the Athwartship beam. Now this is the soft iron structures, a Athwartship beam, which is responsible for generating coefficient D, coefficient delta. Now since this beam is a soft iron structure, it does not have any permanent magnetism or any permanent poles. The magnetism in this beam is induced magnetism, and it is generated by the magnetic field of the earth. So let's now show the poles of the earth in our diagram. You can see the south pole of the earth coming up on the screen at the bottom, and it is having a red polarity. And we can now see the north pole of the earth, north magnetic pole of the earth coming up at the top of the screen, having a blue polarity. Let's also show the magnetic lines of force in our diagram. We are aware that the magnetic lines of force, they come out of the red pole and they enter or they go towards the blue pole of the earth. So you can see the magnetic field lines shown by these arrows. The magnetic field lines are generating from the south pole of the earth, the red pole, and they are going into the magnetic north pole, the blue pole of the earth. Now these magnetic lines of force will be inducing the Athwartship beam present on the ship. Now the starboard end of the beam is the point where these magnetic lines of force are entering, and we are aware that wherever the magnetic lines of force enter, they generate a blue polarity. So you can see a blue pole being generated at the starboard end of the soft iron Athwartship beam. Now the port side end of the Athwartship beam is the point where the lines of force are leaving or going out of the beam, and wherever the lines of force go out, they generate a red pole or a red polarity. So that's why you can see a red pole being generated at the port end of the Athwartship beam. Now these red and blue poles generated at the end of the beam are the ones which are causing coefficient D, which are causing the deviation in our compass. The red pole on the port end of the beam is repelling the north end of our magnetic compass needle. Red and red, they repel each other, and the needle turns clockwise. Looking from top, the needle turns clockwise or in the easterly direction, generating a easterly deviation. Likewise, you see the blue pole which is generated on the starboard end of the Athwartship beam repels the south end of our compass needle, both having blue polarity, blue repelling blue, and again complementing the easterly deviation. So the compass needle turns clockwise looking from top of the compass, and it generates a easterly deviation. Now for correcting this deviation, we use the principle of like cures like. So we correct it using a soft iron corrector. And in this case, we use soft iron spheres. So let's place the spheres. You can see the spheres now coming up on the sides of the compass in the Athwartship direction. There is a sphere on the port side of the compass, and you have the second sphere on the starboard side of the compass. Now these are soft iron spheres, so they also do not have any permanent poles. These spheres will also be induced by the Earth's magnetic field lines. The end of the sphere where the magnetic field lines enter will get a blue polarity. So you see the south end of the sphere. Let's first concentrate on the starboard side corrector, starboard side sphere. You see the south end of the sphere right now where the laser pointer is the point where the magnetic lines of force are entering, and thus generating a blue polarity in that direction. The top end or the north end of the sphere is the point where the magnetic field lines are leaving or going out from the sphere, thus generating a red polarity. Similarly, if you have a look at the port side sphere, the bottom end where the laser pointer is right now is the one where the magnetic lines of force are entering, giving it a blue polarity. And you can now see the points where the magnetic lines of force are leaving or coming out from the spheres, they are having red polarity. So we have the corrector spheres placed in the Athwartship direction of the compass to port and starboard of the compass, and we have these corrector spheres induced by the Earth's magnetic field. Points where the Earth's magnetic field lines are entering into the spheres have got blue polarity, and the points where the magnetic lines of force are coming out of these soft iron spheres have got a red polarity. Now let's first concentrate on the starboard corrector sphere. Now this starboard corrector sphere is having both the magnets, both the poles. You have the red pole as well as you have the blue pole. Now that pole of the corrector affects the magnetic compass which is closer to the compass. Now out of this red and blue pole of the starboard corrector, the pole which is closer to the compass is the red pole. So from the starboard corrector, red pole is what is affecting the compass. And this red pole is going to attract the south end of the compass towards it, thus cancelling out the easterly deviation. When the red pole of the corrector magnet, the starboard corrector magnet, attracts the south end of the compass needle, south end has a blue polarity, opposite poles attract. So when it attracts the south end, the compass needle turns anti-clockwise, thus cancelling out the deviation generated. you can see the starboard end of the beam was having a blue polarity, whereas the starboard soft iron corrector having a red pole closer to the compass is cancelling the effect of the Athwartship beam. Now let's take our attention to the port side corrector. Now in the port side corrector, we are having both the poles, blue pole as well as the red pole, but the pole which is closer to the compass needle is the blue pole. The blue pole is closer to the compass needle, and this blue pole attracts the north red end of our magnetic compass needle. North end of the compass needle having a red polarity, corrector magnet pole closer to the compass having a blue polarity, blue and red being opposite poles attract each other. This also leads to the magnetic needle swinging anti-clockwise looking from top, thus cancelling out the deviation generated. You can also have a look at the end of the Athwartship beam. The end of the Athwartship beam was having a red polarity deviating our compass, and the corrector magnet pole closer to the compass has a blue polarity which cancels out the effect of the Athwartship beam. So you can now see the corrector magnets, soft iron corrector magnets placed in the Athwartship direction, cancelling out the deviation generated because of the ends of the Athwartship beam. So beta, is it clear? Any doubts coming in?
सर वो नॉर्थ ईस्ट क्यों लिया एक बार फिर से बता देंगे जो शिप का हेडिंग इसमें.
ओके बेटा, जब भी हम करेक्शन करते हैं, द करेक्शन इज डन ऑन ए हेडिंग वेयर द डेविएशन इज मैक्सिमम. सो कोफिशिएंट डेल्टा जनरेट्स मैक्सिमम डेविएशन ऑन नॉर्थ ईस्टर्ली हेडिंग, इसीलिए हमने इसे नॉर्थ ईस्ट हेडिंग पे करेक्ट किया है.
ओके सर.
Okay, if you want, you can go to any intercardinal heading beta. You can do it on southeast also, southwest also, and northwest also. On any of the intercardinal headings it can be done.
ओके सर.
और बताओ बेटा, और डाउट्स आ रहे हैं? Okay beta, great, excellent. So this explanation is not suitably covered in the book. This diagram is also not there, and it is only explained in theory. So once you look at this diagram, it becomes crystal clear how the correction takes place using these soft iron spheres. Very good. Now that completes coefficient delta. Okay. Now beta, tell me one thing. Shall we go ahead with eco also? Can we go ahead with eco? चलें बेटा, eco पे चलें? Okay, all right. So let's go to eco. Eco is simple. Eco will not take much of the time. It's very similar to coefficient delta. Eco is basically coefficient delta rotated by 45 degrees. So let me show you. Let's now move on to the next coefficient, which is coefficient E, eco. Coefficient E is very, very similar to coefficient delta. Very, very similar to coefficient delta with only one difference. It has, you can assume it has a phase difference of 45 degrees. Coefficient delta was powerful or the strongest on intercardinal headings, and it was 0 on cardinal headings. Whereas coefficient echo is 0 on intercardinal heading, and it is maximum on the cardinal headings. So very, very similar. Coefficient T is the maximum value of quadrantal deviation. It is again a quadrantal deviation which changes its name every 90 degrees, which varies as the cos of twice the compass course. It is caused by a horizontal field at the compass position due to induced magnetism in the horizontal soft iron situated symmetrically about a 45-degree line through the compass position. So for generation of coefficient T, we need to have a soft iron structure on the ship in this particular orientation. You can see a soft iron structure at a 45-degree angle to the fore and aft line or to the Athwartship line. So normal merchant vessel will not have any structure like these. The fore and aft longitudinal as well as the Athwartship beams are generally the strength members of a normal merchant vessel. So we will not have a substantial structure, a soft iron structure at a 45-degree orientation. And this is exactly the reason why coefficient T is absent in a normal merchant vessel. Let's now see the deviation generated because of this structure. So let's first have a look with the ship on a northeasterly heading. When the vessel is on a northeasterly heading, this structure is perfectly aligned with the magnetic field line of the ship, thus generating very strong poles at both the ends of the soft iron structure. But these poles are exactly north and south of the compass location, thus generating no deviation at all. For generating any deviation, the poles generated should be at some angle to the north-south line or at some angle to the magnetic field of the earth or to the magnetic needle. And in this case, this angle being 0, no deviation is generated. Now let's take the ship on a easterly heading. With the vessel on a easterly heading, we can see that this structure is now partially aligned with the magnetic field of the earth, partially aligned. So the poles generated are of the partial power, but these poles are at a 45-degree angle. This is where maximum deviation is generated by these poles. So on the easterly heading, you see maximum deviation is generated. In the previous case, with the vessel heading in the northeasterly direction, the deviation generated was 0. So on an intercardinal heading, the deviation generated is 0. On a cardinal heading, the deviation generated is maximum. Now let's take the ship on a southeasterly heading. When the ship goes on a southeasterly heading, you see this structure is now at right angles to the magnetic field of the earth. So being at right angles, the induction is 0, negligible, no poles are generated. With no poles being generated, the deviation generated is also 0, so nil deviation on southeasterly heading. So you see 0 deviation on the intercardinal heading and maximum deviation on the cardinal heading. If you look closely, this entire deviation diagram is very much similar to the diagram of coefficient delta, as if the coefficient delta diagram has been rotated by 45 degrees. So that's why I said there is a 45 degrees phase difference between delta and echo. Here beta, is it clear?
Yes, sir.
Very good beta, great. You can see the deviation represented here. This is the heading of the ship, north, northeast, east, southeast, south, and so on. And the curve shows the deviation generated. Maximum deviation on northerly heading, 0 deviation on northeast, maximum deviation in the opposite direction on an easterly heading, 0 deviation on southeast, maximum heading in the opposite direction on a southerly heading, and so on. Now moving forward to the correction of coefficient T. As we discussed, on a normal merchant vessel, coefficient T would be absent as there is no substantial structure at a 45-degree angle to the fore and aft line of the ship. However, if it is present, the correction is done exactly similar to coefficient delta using soft iron spheres. But in this case, the spheres are placed diagonally. In the same direction in which the structure lies, the spheres are placed in the same direction. If you remember, we did the same thing in coefficient delta also. The beam in that case was lying in the Athwartship orientation, so the soft iron correctors were also placed in the Athwartship direction. In case of coefficient E, the structure is at a 45-degree angle, so that's why the corrector are also placed at a 45-degree angle to the fore and aft line. So in this diagram, you can see this is the case we discussed in the deviation diagram. We have a structure in this particular way. The soft iron spheres are placed in the same orientation, thus cancelling out the effect of the soft iron structure. Clear, beta? Understood? Great.
Yes.
Now, in case on a particular ship, coefficient D and coefficient E, delta and eco, both these coefficients are present together. When both coefficient delta and eco are present, they can be corrected by using a single set of spheres. We do not need to use two separate set of spheres. Coefficient delta is corrected by placing the spheres in the Athwartship direction. Eco is corrected by placing the spheres at a 45-degree orientation to the fore and aft line. But if both of them are present, they can be corrected using a single set of spheres which are slewed or turned to some intermediate angle in the direction of the resultant of both these coefficients. Now, how do we decide what is the direction in which the spheres should be placed? If it was only delta, the placement was simple. They need to be placed in the Athwartship direction. If it was only eco, the orientation was similar to the structure present on the ship. But if both are present, a single set of sphere can be placed and slewed. The slew angle is calculated by the formula tangent of twice the angle of slew is equal to coefficient eco divided by coefficient delta. So whatever is the magnitude of eco divided by the magnitude of coefficient delta gives us tangent of twice the angle of slew. So angle of slew can be obtained using this formula. Moving ahead. Once the slew angle has been calculated, the spheres are initially placed to correct coefficient delta. For correcting coefficient delta, the spheres are placed in the Athwartship direction. After correcting delta, the spheres are now slewed by that particular angle. Now, how do we decide whether the spheres are to be turned or slewed in the clockwise direction or the anti-clockwise direction? Practically on board, it is very simple. Once you have placed the spheres in the Athwartship direction, they should be slewed towards the direction of the structure which is at a 45-degree angle to the fore and aft line. So in whichever orientation the 45-degree soft iron structure is present, the sphere should be slewed towards that structure. Theoretically, it can also be obtained, it can also be found. If delta and eco are of the same sign, both are easterly or both are westerly, the spheres are slewed clockwise, and if they are of opposite signs, the spheres are slewed anti-clockwise looking from top. Now, after obtaining the slew angle, after obtaining the direction in which the spheres are to be slewed, the next question which the compass adjuster has to be clear about is, what is the heading on which the ship should be when this combined correction is being done? If it was only coefficient delta, we know the vessel has to be on any one of the intercardinal heading, that is where it is the strongest. If it was only coefficient eco, we know the vessel should be on some cardinal heading, that is where coefficient eco is strongest. But when we are having a combined correction of delta and eco, what should be the heading of the ship? Now for this, the maximum deviation due to delta and eco combined occurs when the spheres lie in the northeast or southwest direction of the compass location. Reason being that any horizontal soft iron will produce maximum deviation when they lie in the northeast, southwest or northwest, southeast of the compass location. Let's try to understand this using a diagram. Okay, now this concept will become all the more clear by looking at a practical question which has come in the exam. Now we are running short of time today, so let's keep it for tomorrow beta. कल मैं आपको ये न्यूमेरिकल दिखाता हूँ. इससे ये जो करेक्शन प्रोसीजर है ना, करेक्टिंग डेल्टा एंड इको टुगेदर, ये क्लियर हो जाएगा. इस क्वेश्चन में आप देखोगे दैट देयर इज ए शिप इन विच द डेल्टा एंड इको बोथ द करेक्टर्स आर देयर and the spheres are turned. So we will see what is the heading on which the correction is done and how this is taken care of. Go ahead with your doubts, beta.
Sir, till now, whatever we have learned, on that
Right.
basis, only one numerical is we can expect, that is the combination of B and C.
Yeah, that's
Or
correct, beta. That's correct. This is the second one which you are seeing.
okay.
Okay. This we will do tomorrow because it will take some time. So this is the second one. Actually, इनको numerical नहीं बोला जाता है. They consider it a theory question only. But since it involves some of the headings, you can call it a numerical. Okay, all right. So, shall I close out the presentation now, beta?
Yes, sir.
Okay. Okay. So tomorrow when we do this, the correction of delta and eco together will become clear to you. So today basically we have completed our coefficients, completed up to eco. Tomorrow we will see this numerical, and after this numerical, now there are two important things which are remaining. One is the healing error correction. So sometime you get a straight away 25 marks question on explain the healing error and how this healing error is corrected. So that is one thing which remains. And second is the total compass correction, full procedure right from beginning to end. Till now we have seen the correction of all the coefficients individually, how these coefficients are corrected. Tomorrow we are going to see how does a compass adjuster does the total compass correction, the entire procedure right from beginning to end. So these are the two items which we will see, and along with these I will also show you some typical questions which have come in the exams, which are not the usual theory questions, which are slightly tricky and complicated. We will see some of those numericals also tomorrow. Okay, so let's close out the presentation. Great, beta. Anything else you want to ask or share?